We are now going to be looking at angle of elevation and slope. So for this topic, you're going to have to remember how to use the tan button on your calculator and the inverse tan button. So try these questions at the top of the page, and I highly recommend that you try them to make sure that you're entering these numbers correctly into your calculator. So for tan of 26, you would just hit the regular tan button on your calculator. And tan of 26 should give you 0.4877 if you put that in your calculator. The tan of 78 over here would give you 4.7046. So make sure you can get those two. And now for the inverse tan questions, make sure you're looking for the tan -1 button on your calculator. There might be an X here after it, or maybe a blank space like a square, but make sure you're looking for the one with the little -1 exponent. That is the inverse tan. So now if you do inverse tan of 1.45, you should get 55.407. And just a reminder that when you do inverse tan, it's actually giving you the degrees of an angle. So this here was 55.407 degrees. And then for this last one, the inverse tan of 1/2 or 1/2 should give you 26.565 degrees. So now let's look at some problems. We have Leo is installing a guy wire on a telephone pole. The wire needs to be anchored 50 feet from the base of the pole. The wire must be attached to the pole at a height of 30 feet. So they gave us a nice diagram of this situation. So here's where the wire is going to be anchored. It's 30 feet up the pole, as you can see on this side of the diagram, and it's also 50 feet away from the pole, as you can see on the bottom here. Now it's asking us what is the angle of elevation of the guy wire with the ground. So when we're talking about angle of elevation, how you want to do it is you want to have a starting point, and from that starting point, you want to go straight horizontally out like this and then up. So when you do that, it'll make a triangle like this between your horizontal line and where you went up. That angle right in here is the angle of elevation. Okay, so get some practice at that where you have a starting point and then you go horizontally out and then up from that. And then the angle within here is the angle of elevation. So if we have our starting point down here and we go horizontally out and then up, our angle of elevation is going to be this angle in here, so that X degrees that they have labeled on our diagram. So to find this angle of elevation, really all it is trigonometry that you should have done in grade 10 last year. But really, when we're doing this trigonometry, we're using slope. We're doing rise over run. So our first step is to find the slope of this line. So we are going to do our rise, and remember, rise is going up and down. So the rise here is 30, and then the run is 50. So if we do 30 divided by 50 on our calculator, we will get 0.6. So now we're going to use our slope to figure out the angle of elevation. So they have here that the slope is equal to the tan of x degrees. So I'm just going to put 0.6 because that's what we got for our slope. And then that's equal to the tan of x degrees. So in order to find out what degrees this is, what x is, we need to do the inverse tan of 0.6. So inverse tan of 0.6, make sure you know how to put that in your calculator, and then you should get 30.963 degrees. So the angle of elevation of the guy wire with the ground is, well, we can just round it up, is approximately 31 degrees. So the angle within here is 31 degrees. Now, I just want you to think back to trigonometry last year for a second. You probably learned SOHCAHTOA at some point. And if we look at just the TOA part of SOHCAHTOA, that is tan is equal to opposite over adjacent. And if we're dealing with this angle right over here, and we're trying to find that, well, the opposite side to that angle is 30, and the adjacent side is 50. So when we did this step over here, all we really did was opposite over adjacent, which is how we got that 0.6. And then we had to do the inverse tan of that in order to find the actual angle. So this is just like another way to view trigonometry, except now we're viewing it in terms of the slope. In the next example, it says that Bev makes handcrafted kites. She is testing a new kite. She looks up along the kite string at an angle of elevation of 20 degrees. What is the slope of Bev's line of sight to the kite? How is the slope related to the angle of elevation? So let's just look at the picture, the diagram they give us over here. So we have the kite up in the air, and then this is Bev way down here holding the kite up. So remember, her angle of elevation is going to be that straight horizontal line out and then up from that. So within here, and they give us that the angle of elevation is 20 degrees. So this angle here is 20 degrees. So in part A, they want us to start off with what the slope of this line is. So we need to do rise over run. So the rise this time is 91 feet and the run is 250 feet. So they have rise over run, and then if we put that in your calculator, you should get 0.364. Now this decimal here is actually going to be the same as the tan of 20. So the tan of 20 degrees is equal to 0.364. And the reason for that is, well, the tan of that 20 degrees there is equal to opposite over adjacent. And our opposite value here is 91. Like the opposite of this angle is 91, and the adjacent is 250. So really, we're just doing the exact same calculation that we did over here. So that is why the tan of 20 degrees is equal to 0.364. So the last part here, it says, how are the slope and the angle of elevation related? Well, we will say that the slope equals the tangent of the angle of elevation.